Hello, this is Concrete Path. Here we have the lecture for water content determination. Water content determination. Water content determination. So here we say that this water content determination, that why water content determination? We say that water content is actually your important soil parameter. It's your important soil parameter. If you talk about that clays, slits, that's fine grained soils. So for the cohesive soils, we say that this is very important parameter. And before all other tests we perform, before all that is before all tests, before all strength tests, whatever test we are performing related to the strength, this test is important. That water content determination is this test we have to perform before that it is performed. Why? Why we are performing this test? Because we say that the properties of the soil are influenced by the water content. So that strength parameters are also going to change because of this water content change. We say that water content changes with storage, it changes with transportation, changes with time. So changes with time, storage, transportation. So this becomes important that before you have any strength value of soil, we should say at what water content this value was achieved. So storage, transportation. So this is we say that it's going to change with these conditions. And similarly, if you talk about the properties of the physical properties also, if you talk about the physical properties of soil also, that physical properties of the soil, like we say that how you can convert from the bulk weight, you can get the dry unit weight of the soil if you know the water content of the soil. So similarly, all other properties are also calculated based on the when we have calculated the water content first. So for that, for calculating the water content, we say we have few methods to begin with. We have few methods, and we say that water content determination is actually accurate because water content is actually weight of water by weight of solids. So we have the calculation of water that we have to calculate weights, and weight calculation is easier. It's more we can say more correct. Uh, this is calculations of weight. We have calculations of weight, and weight calculations are more accurate than volume calculations. So if you have calculated the water content, that means it would be very accurate value. So for that, now we are going for the few methods we have related to water content. First one is that a standard lab test that we call as oven drying method. Oven drying method. This we say that this is your standard lab test. Standard lab test. And this is very accurate value. It gives very accurate values. So here what we do, we have a pan. Let's say that we have a pan, small pan, and inside that, let's say this is pan, and the weight here is W1, weight of the pan. Now we are going to place that soil inside that, and the soil is moist soil. Soil is moist soil, and the pan is also there. So we call it as W2. After that, we are going to keep it in the oven. We are going to keep it in the oven for we are going to keep it in the oven for 24 hours at temperature of 105 to 110 degrees Celsius. At this temperature for 24 hours, such that your water gets lost and you are only left with dry soil. This is dry soil. Now you are left with only dry soil, and the total weight of that assembly is we can say this is W3. So that we have these three stages. We have to calculate these three weights. After that, I would say then you can calculate water content. So you can calculate water content is equals to weight of water by weight of solids. Now what is the weight of water from these calculations? I would say that if you take that W2, if you say what is the value of W2, minus W3. Is that weight of water? Because all the system is same in the second and third, except that water is lost because of oven. So this is actually weight of water that has lost because of oven and 24 hours. So W2 minus W3 divided by weight of solids. What is the weight of solids? Actually, weight of solid is the difference of W2 minus W1. W2 minus W1. So this is the calculations for water content. So this is very easy and very accurate. And we say that you're keeping the temperature for at this range 105 to 110. If you keep the temperature greater than 110 degrees Celsius, your soil, we say soil is also having some water inside that we call as structural water. This is also going to be lost. So this is some sort of water in the minerals, in the clay minerals itself. So this is we say that this is structural water. This is not going to be lost for a temperature less than 110. So if you increase the temperature beyond that, your soil is going to break. Your soil structure is going to break. The soil is composed of soil is having some structure, and in that particular structure we have water that's called as structural water that's not lost before that if your temperature is less than 110. So we are going to keep the temperature lesser than 110. And one more thing is there, if the soil is having organic matter, organic content, if the soil is having organic content, organic matter, we can say organic content. Some soils have organic content, organic content, organic matter. Let's write organic content. In short, we can write organic matter. So for those, that organic matter can get lost, and you would get a very that you would get accurate value then, because that organic matter is going to burn, that's going to oxidize. So finally your reading would be less. So it's recommended that temperature should be within range of 60 to 80 degrees. It's recommended. Otherwise the reading would be inaccurate, because that organic matter is going to be lost. So you would think that water has been lost, but that organic matter has been lost. Okay, this was your first method, that's oven trying method. That is a standard lab test. Okay, let's go for second one that we call as pycnometer method. Second one is there that we call as pycnometer method. Second one, pycnometer method. So what is this pycnometer actually? So this is actually a pycnometer is actually a standard glass jar. Glass jar is there of around 1 liter capacity. 1 liter capacity is there of this jar. It's a glass jar, and it's having some lid, or a cap is also at the. There is a cap also. So in the cap there is a hole of diameter 6 millimeters in the cap. So there is hole of 6 millimeter diameter in the cap. Okay. So what is the procedure for calculating that what you call as water content? Let's have a general view that let's say that this is our weight of the pycnometer. Let's write it, this is only W1, that is only pycnometer is there. Pycnometer, weight of the pycnometer is W1. Okay, after that we are going to place from the top, that from this side we are going to place that soil inside. Let's say we have placed the soil inside, some value of soil is there. Let's say this is our soil. And we can say this is moist soil, because we need to calculate water content. That means there should be some water inside the soil. That's your moist soil. Let's say that this is your what you call as W2. Let's say this is W2. That is weight of moist soil plus weight of pycnometer. That is W2. After that there is third reading. Third reading is there. That means up to this level this was only moist soil. This was moist soil. Now we are going to place what you call as water also. This is water. This is moist soil plus water plus pycnometer. That is W3. That is W3. After that, we are going to place only water inside. Only water. In the fourth reading, only water is there. Only water. So this is only water. That means we have to remove that all the soil from the inside. Then after that, place only that what you call as water inside. So we can say this is W4. That is the weight of water and weight of pictometer, W4. Now we need to calculate what's called as water content. What is the equation for water content? Water content is actually weight of water by weight of solids. So what can you say that what is the weight of water from this diagram? Weight of water. Weight of water. So if you talk about that, from the reading 2 and reading 1, can you get any value? If I say what is W2 minus W1? If I say what is the value of W2 minus W1? So W2 minus W1 is the weight of moist soil. Is the weight of moist soil. Can we say that? W2 minus W1 is the weight of moist soil. And that weight of moist soil is actually, I would say, that is actually weight of solids plus some weight of water. Can we say that? There is some weight of soil and there's some weight of soil because the moist soil is there, so it's having some solids and it's having some little bit of water. So that's this part we need to calculate. What is the weight of water? So how can we now say what is the value of WW? So I would say WW, weight of water, is actually W2 minus W1 minus weight of solids. So this is one of the part we got. Weight of water equals to W2 minus W1 minus WS. Okay. Now we need to calculate what is the weight of solids itself. What is the weight of solids? So to calculate the weight of solids, there's very important things we have to perform. So to calculate the weight of solids, we have to perform very critical things here. So we got the weight of water, but we need to calculate now what is the weight of solids. What is the weight of solids? Equation becomes there, weight of water by weight of solids. In that part also there is weight of solids. In this part also there is weight of solids. But we have not calculated, but our reading is only that we have calculated W1, W2, W3, W4. We have not calculated weight of solids. So how can you calculate based on these four? How can you get the weight of solids? That's the thing we need to do. That's the thing we need to do. Okay. Let's say that I want to say what is the value of W4 minus W1. So this is the extra part we have to perform. What is the value of W4 minus W1? What is the value of W4 minus W1? W4 minus W1. So actually W4 minus W1 is actually, let us say that this is having some that's what we call as, let's say that here the volume is, let's analyze further. See this moist soil. This is your moist soil. So it's having some total volume of V for this soil. So I would say I can transform it in this way that we have some weight of solids. This is our weight of solids, and it's occupying that volume of solids, and there's some little bit of water also. There's some little bit of water, weight of water for small volume of water, I can say. After that, the left part, that's this part, I can say this is some value of V1. Let's assume that this is some value of V1. Okay. Now I would say, what is the value of W4 minus W1? W4 minus W1. So I would say W4 minus W1 is actually, this is the extra things we have to perform. Then finally we write that what is the value for W4 minus W1. To get the understanding that how we are getting this, so we need to do some stuff here. W4 minus W1 is actually all the volume of pictometer is filled. That means all the volume of pictometer is filled with water. That is the difference between W4 minus W1. Can we say that? So W4 minus W1 is actually volume of solids plus volume of water plus V1 times gamma W. That is the weight of water for the entire volume. That is the weight of water for the entire volume. Gamma times volume. So I need to say, I need to equate it with W3 minus the W3 minus W2 maybe W3 minus W1. If I also say what is the value of W3 minus W1, if I say what is the value of W3 minus W1, can you tell me what is the value of W3 minus W1? So by subtracting that W3 minus W1, that means weight of the pictometer is gets cancelled. Only the part that is left is actually that's actually left here. That is the V1, volume of V1 for the water, and there is little bit of water also. There was little bit of water here also, that we write as volume of water, and there was volume of solids also. So I would solve that in this way, that we have W3 minus W1 is actually some volume of V1 times gamma W, some V1 times gamma W, and plus some volume of water times gamma W, and some volume of solids times some volume of solids times gamma solids, so that we can directly write that this is weight of solids. So this part is actually weight of solids. Can you say that this part is directly weight of solids? So this part is actually weight of solids, somewhere here. If I make the phase diagram, this is our phase diagram for the understanding. Okay, so now I need to equate that W4 minus W1 with respect to W3 minus W1. I want to see whether we can have an equation between those. If I write W4 minus W1 should be equals to W3 minus W1, is it correct, or we need to do some more stuff here? So why we are doing this? Our equation should be in terms of W1, W2, W3, W4, because we are calculating these values in the test. In the test, we are only calculating these four values. So our equation for water content should be in terms of that W1, W2, W3, W4. That's why we are calculating in terms of that. So W4 minus W1 minus is equals to W3 minus W1. Is it correct? So what is missing? Can you see what is missing? So I would say, if I try to calculate this part, this was your volume of solids gamma W plus volume of water gamma W plus volume 1 gamma W. This equals to volume 1 gamma W plus volume water gamma W plus weight of solids. Is it exactly correct? Is this exactly correct, or there we need to perform any other thing? Let me check. Let me check. This is weight of solids into gamma W. This is the weight of solids. I think we are missing something. I think we are missing something. Yeah, this is not the weight of solids actually. This is not the weight of solids. This is not the weight of solids. This is the weight of water for this volume of Vs. This is not the weight of solids. So this part is getting cancelled. This part is getting cancelled. This part this part gets cancelled. This part gets cancelled. So we are left with that. We are left with that what you call as some parameter here, some parameter here. So we need to how can you equate that? You should say 1 is equals to 1. So that means you should add some part here also. So I should subtract. Now I need to subtract this equation. If I say we subtract Ws and we add Vs gamma W. If I do this stuff here, I have to perform this stuff here. Now I had to write that W4 minus W1 is equals to W3 minus W1 minus W solids plus Vs gamma W. This is the extra part we have to add here. Such that finally your equation becomes 1 is equals to 1. So that means your final value of that W4 minus W1 is actually W3 minus W1 minus W solids plus Vs gamma W. So this is the important parameter tool we got here. Parameter equation. Important equation we got. And from this we can get the weight of solids. We can now get the weight of solids. Now if I say what is this volume of solids? What is this volume of solids? This is actually weight of solids by G gamma W. Can we say that? So we got the volume of solids actually Ws G gamma W. Let's try to substitute that value here. Let's try to substitute that value here. I would write W3 minus W1 minus W solids plus weight of solids by G times gamma W. Now I want to say what is the value of W solids from this calculation, from this equation. From this equation, I would say what is the weight of solids? Weight of solids. So I can simplify it further. I would say this becomes W3 minus W1 and minus Ws solids. Then we have 1 minus W solids. Sorry, W1 minus 1 by G times gamma W. In this way we can write. Yeah, actually what was one more part was there. This was only volume of solids. This is actually volume of solids. but our equation is volume of solids times gamma W. So we have to multiply gamma W also, such that it's going to get cancelled. This gamma W goes to cancelled. This goes cancelled. So only now you are left with that minus W weight of solids common outside 1 minus 1 by G. So this part is left, and this is equals to W4 minus W1. Now I want to say, what is the weight of solids? Can you calculate the weight of solids now? Weight of solids. I can solve it now. Weight of solids into 1 minus 1 by G is actually equals to W3 minus W4, because this part goes cancel with this one. So you are left with W3 minus W4. So I would say weight of solid is actually W3 minus W4, and this can be solved that this is actually what you call as G minus 1 by G, G minus 1 by G. So such that this part becomes G by G minus 1. So this is the weight of solids we got now. Weight of solids. Is it the same? Yeah. Now we need to substitute the same value of weight of solids in the actual equation, that we have water content equals to weight of water by weight of solids. So we need to substitute that all stuff here. What was the equation for weight of water? What was the equation for weight of water? This was the equation for weight of water. W2 minus W1 minus WS. W2 minus W1 minus WS. And we have this divide of WS. So from this we can simplify it in this way, that we have W2 minus W1 divided by WS, then we have minus 1. Now we need to substitute that weight of solids. Let's substitute the weight of solids. So W2 minus W1 divided by weight of solid is W3 minus W4 into that G by G minus 1 and minus 1. So final equation is there. So this is the final equation, that water content is equals to W2 minus W1 divided by W3 minus W4 into that G minus 1 divided by G. This is the equation for that water content calculations. I hope you got that equation. Okay. Now, so from this equation we can conclude that this method is only applicable. You can use this method only, or you can say this is used only when you are going to use this method. See, W2, W1, W2, W3, W4, all these readings you can calculate. You can calculate in the test, during the test. So that is easy. You can calculate that. That's not big task. You would keep that on the weighing machine, so you can get W1, W2, W3, W4. But what is one more parameter we have to calculate? There's the role of G here. So I would say, if G is known, only then you can calculate water content. So this can be only known after that if your value of G solids, if your specific gravity of solid is known, then only then you can calculate water content. So there is a limitation for this method, that we must have the value of G first. We should know the value of G for this kind of soil. So G should be known to us at earlier time. So we have to ensure that we know the value of G for this kind of soil. Otherwise, you won't be able to solve that water content calculations. So there is this is the what you call as limitation. This is the limitation we have. Now there's one correction here. There's a possibility of correction. There's a possibility of correction. That is the third weight of W3. That is the W3. Actually, the glass jar is in this way. Picnometer bottle is in this way. Okay. Let's say that this was your bottle. Let's say that there was a bottle. Okay. Let's say this was your bottle. And there is a hole also at the top. What is the role of this hole? The whole role is there to release the air that's entrapped inside. To release the air entrapped in the voids inside. In the voids. Now, what we are going to do? Let's say that what you call as, why we are adding this water? Why we are adding this water? This V1 water. So this is to ensure that to remove all the voids. This is to ensure that this V1 is added in order to ensure that that we want to calculate what is the volume of solids. What is the actual volume of solids here? What is this part of volume? uh, for that we are adding this much amount of water. We are adding this much amount of water. And if the voids are not completely filled, if the voids are not completely filled, that means there would be that error in the calculations. See how we are going to say. Let's say that there was only granular soil. Let's think of sand only. That means there was only sand. Let's say this was sand. These were your grains of sand. And if you not pour the water inside, if you not pour the water inside, that means there won't be any void left. Void left is equals to zero. If the grains are sand grains, that is cohesionless soils, that we call as cohesionless soils. Cohesionless soils. If the soils are cohesionless soils, in that case voids left are 0. That means your water W3 that what you call as W3 value of that reading, W3 reading would be correct, is correct. That means we don't have to apply any correction. Now let's think that you were having that clay that we call as cohesive soils. Let's say that we had clay, or we can say cohesive soils. They are having finer those finer particles. They are having cohesion also. Let's say there was soil. This is your soil. This is your soil, and there's a possibility that that the water now you are applying. If you are applying the water now for the reading, third reading, now there is a possibility that all the voids won't be filled with water. All voids are not filled with water, or not filled with water, or voids are not filled with water. That means air. There is some air left. There's some air left. So your W3 is not correct. W3 is not actually correct. So to calculate the actual value of that W3, I would say let's assume that the volume of air actually was, this is the volume of air that is left. Volume of air entrapped. Let's say that this is the volume of air entrapped. If I got somehow that we have volume of air entrapped equals to VA, then means how we would say W3 actual would be equals to initial value of W3, and we have to add one more part. We have to add one more part because this volume of VA was occupied by air, and air is having 0 weight. So if there was water, that means we would have some one more weight of water. That was actually this much amount of water. This is the weight of water for the volume of VA. So this is the actual W3 for that calculations. And finally you can write there that what is the equation we have. So here we can write then finally we can finally write that in there. This one we can modify here. Finally this one is your W3 modified. Okay, so that means your pygnometer method is suitable for cohesionless soils. So final statement we can write that where this method is applicable. So finally we can have the statements that this method, pygnometer method, is applicable if your G is already known. G should be known to us. Okay, your soils are having C equals to 0. That means soil should be cohesionless. If there is C, that means if there is clay, let's say this is cohesive. Here we have what? There is air, air entrapped. There is some volume of VA. So this is not suitable for this method. So our pygnometer method is suitable for cohesionless soils. Okay, let's go for the third method. Let's talk about third method. Let's have the third method that we call as sand bath method. So what's this method? We have a big vessel, large vessel is there. Now inside that we are going to place that sand grains. Now, sand is placed here. This is some sand is placed here. Now we are going to heat it. Let's say we are going to heat this what you call as vessel. Heat the vessel. Okay. Because of that, sand is also going to get hot. So sand gets hot. Okay. Now now we are going to do? We are going to get some pan. Let's take some pan. Let's say this is some pan of weight of W1, or we can write this is also some tray. Weight of pan, or we can write this is some tray. Let's go to actual, like let's say that this is tray. Let's say that this is tray. This is the weight of tray W1, and we are going to place that tray at the top when the vessel was hot and that sand was also hot. At that time, now we are going to place that tray on the top of that sand. Okay, and now in what is the reading W2? We are going to place some soil. Some soil is there, moist soil. So moist soil is inside there. So that means we are having some soil, moist soil inside that tray of weight W2 of a W2, that is the sum of that tray plus moist soil. After that, after some time of that heating that tray, you are getting that dry soil now. You're only left with dry soil. Dry soil is only left, and we have that weight of tray also, so we can write this is your W3, and then finally we can write what is the water content. What is the water content? So water content can be solved as weight of water by weight of solids. So weight of water is actually the difference of W2 minus W3. W2 minus W3, and weight of solid is the difference of W3 minus W1. So that is the water content calculations. And we say that this method, we are going to, this is used that it takes around 20 to 60 minutes of that drying. That means you are keeping that tray for 20 to 60 minutes on that sand bath. So it depends on the this range. It is a function of soil. So it depends on the function that soil. Also, we place one more part here that we call as piece of paper. Let's say that this is white piece, white page of, or we can write piece of paper, white piece of paper. And this is a white paper piece. A white piece, white page, a little bit of page is there. So we are keeping that. Now, what is the role of this? We say that if there is overheating, of the soil, so that indicates that this page is going to, this page is changing color. That means it's going to get brown kind of thing, browns. So maybe this color gets appears. So that indicates that you are overheating that soil. So we need to that change those soil orientations such that you are properly applying that heating of the soil specimen. Okay, so sand bath method is there. So this is we say that this is field method. You can apply it in field method, and this is very rapid because it's only taking some 20 to 60 minutes of calculations. And but the calculations are not accurate, but it's not more accurate as compared to the others. It's not accurate, I would say. It's not accurate. It's not accurate. It's rapid. It's quick, but it's not accurate value giving. Okay. Now fourth method is there, torsion balance method. Fourth method is there, torsion balance method. Torsion balance method. Torsion balance method. So in this one we have two equipments. One is called as infrared lamp, and one more is there that's called as torsion balance moisture meter. Torsion balance moisture meter. Here what we are going to do in this method, there's simultaneous. One is your weighing, simultaneous drying and weighing. So your lamp is going to dry that soil, drying, and there is that weighing also simultaneously. There is drying and weighing of soil simultaneously. So this method is then, I mean, this is useful for those soils, that what they are going to do. Useful for soils that quickly reabsorb the water, reabsorb moisture. Uh, Once they are dried, they suddenly can reabsorb the moisture upon drying. Okay, right here. So this is the it. We can say this is the all stuff from this method, torsion balance method. So this method is useful for soils which quickly reabsorb moisture upon drying. So that's your torsion balance method. Okay. We can write that. One more method is there, calcium carbide method. Calcium carbide method. Here, what's the concept? Here we say that there is some calcium carbide, and whenever it reacts with water from the soil, whenever it reacts water from the soil, it is going to release acetylene gas. It's going to release acetylene gas plus some more compounds. Let's say that it releases that gas, and our calculation for water content is that we get indirectly the value of water content. Indirect water content determination. Indirectly we get this water content from the calibration that we have acetylene gas, and from that we can get the pressure on that pressure gauge. So from this we get some pressure. From the pressure we are going to get the water content. So your pressure is related to the water content now. Pressure is related to the water content. Pressure is related to water content. And this water content, what we got, this is not the actual water content. So this is the water content we got. We get, this is actually percentage of water. Actually, this is the percentage of water we get. This is water content based on total mass, based on total soil mass, based on total soil mass. We are not getting, our water content is actually weight of water by weight of solids. But we are not getting this. We are getting actually, so we are getting WT, that we write as WT, that is water content based on total mass. So that is weight of water by weight of total weight of soil. Here we have this one, this is weight of soil. Now we need to convert it from the calculations. Once we got the WT, so this value, our method, that calcium carbide method, gives you value of WT. It gives you value of WT. From that we need to now calculate by our calculations that what is the value of actual water content. What is the value of actual water content we need to calculate from this one. So if I say that your WT is actually the weight of water by total weight of soil. Okay, your total weight of soil is actually weight of water plus weight of solids. And from this we can simplify further. I will write WT times WW plus WT times weight of solids is equals to WW. And we can write WW1 minus WT is equals to WT WS. And from that we write WW by WS is equals to WT by 1 minus WT. And this part we know this is actually water content. This is actually water content. So our water content is actually total water content minus 1 minus times total water content. So this is the equation we have final. So this we need to calculate, but your method is actually giving you value of WT. So this is from the method. So this method is obtained, this value is obtained from the calibration, that pressure versus water content. And from that you got WT. Now you need to calculate actual water content from this result. Okay. So this one is your indirect method of water content determination. Final method is there, that's a radiation method. Little bit we are going to talk about that. Radiation method. That is the number 6, I think. Radiation method. So here we are using those radioactive isotopes. Radioactive isotopes like that of a cobalt 60. Cobalt 60 is there. And there is what we call as, there is scattering of neutrons. There is some method by that. There is scattering of neutrons because of the hydrogen, because of hydrogen atoms from the soil water. That is the water because of the soil. The water present in the soil, they are having some hydrogen atoms. Because of those, there is scattering of neutrons, and there is some loss of energy. And we say that finally loss of energy we have because of that scattering, that is proportional to the water content, quantity of water present in the soil. Then from that we can get what is the water content, quantity of water in the soil. Okay, this is your radiation method. Okay, that was all from for the water content determination. That was all from the water content determination. Well, now we have a little bit of, we have to talk about a little bit about that specific gravity determination. Specific gravity determination. Specific gravity determination. That's actually specific gravity of solids, soil solids. That is the GS. We need to determine how do you estimate this value of GS. We have one of the methods that was pictometer. we studied picnometer method. From that we got some value of water content was some value of W. What was the equation for that water content? So there we have that equation W2 minus W1 divided by W3 minus W4, G minus 1 by G minus 1. So there was the role of that value of G. So that value of G can be determined by this method of that specific gravity determination. And in this case also we are going to use picnometer bottle picnometer. So we have one method here, that is the picnometer method. So we are going to use that same picnometer. We are going to use that same picnometer. We are going to use that same picnometer. And in this case, our soil mass should be dry. Soil mass is equals to dry. It should be dry condition. It should be in dry condition. Soil mass should be in dry condition. Soil mass should be in dry condition. But during the water content determination by using picnometer, there the soil mass was moist soil. Here we use a moist soil because we need to calculate water content. For that we must have a moist soil such that we can get water content. But here for the same picnometer bottle we are using dry soil. Keep that in note. We are using dry soil. And let's go for the calculations of G. Can you tell me what is the value of G? What is the absolute specific gravity? G. What is the value of that? Is that unit weight of solids by unit weight of water? And what is the equation for gamma solids? Is that weight of solids by volume of solids? And this is your gamma W. Okay, so this part we have to determine. Let's say that we have that same picnometer bottle. This is some W1, that is the picnometer only. This is picnometer. After that we are going to have some soil. Let's say this is our soil placed here. This is the weight of solids and this is the volume of solids. This is we can write this is only dry soil. It's not moist. If it is not moist, that means we don't have any water left. We don't have any little bit of water. We don't have that. This is only that dry soil. So I would say there is only dry soil. So only there that this part is only dry soil. Let's say this is only dry soil. Okay. And we can call this one, you can measure the weight total, that is W2. After that, we are going to fill the rest part of the picnometer by water. Rest part of the volume, we are going to fill that by water. Let's say up to this one, we had that weight of solids and we have that volume of solids. Now we are going to place some water also. This is volume of water, this is weight of water, and this is volume of water. Let's say this we are going to write as V1. Let's say this is the V1, we are going to write V1. After that, this is our W3, and finally we can write W4. We can write W4 now. W4 is that we are only filling the water inside the entire volume of the bottle of that picnometer. We are going to have only water. That is the weight of water. And this is only this is the volume, total volume. And what is the total volume? Can you tell me what is the total volume? Total volume is actually V1 plus Vs. This is the total volume, and we can write this is W4. And W4 is actually weight of water plus weight of picnometer. Full weight of water plus weight of picnometer. Now, what's actually what I call as G? So G can be solved as weight of solids by volume of solids times gamma W. So your weight of solids is actually how much? Can you tell me what is the weight of solids from W2 minus W1? If I write what is W2 minus W1, what is that? So that's actually the difference of weight of solids plus weight of picnometer minus weight of picnometer. So finally that is actually weight of solids. So we got the value of Ws. Now how can you get the value of this Vs gamma W? Can you tell me what is the value of Vs gamma W? What this means? This means we are having a fluid of unit weight gamma W, and it's occupying volume of Vs. So that's actually we call it as weight of water, weight of equivalent volume of water, So that is the definition of G of solids. That means your G of solids is actually weight of solids. Your solid your specific gravity is actually weight of solids divided by weight of equivalent volume of water. Equivalent volume of water. That is the definition of that what you call as specific gravity of solids. So that means you are having some weight of solids Ws, but that would be occupying some space. That would be occupying some space. I would say weight of solids in volume of solids in this volume of solids, and we are having that what is the weight of water in same volume of Vs, in the same volume of Vs. That if I write that, that's weight of solids by volume of solids by weight of water by volume of water. Volume of water, but your volume of water is actually here we are talking about same volume of solids. So that means this is actually gamma solids by gamma W. That's your G. But your volume of solids, volume of water should be equals to equivalent volume of solids. So VW is actually equals to Vs. And now we need to calculate what is the how can you get this part? How can you get this part? That means from the diagram we have to see anywhere that total Vs. We need to see where is the volume of Vs. We need to see where is the volume of Vs and that's only filled with water. That's only filled with water, and that we can see in the diagram 4. So we are having some volume of water, that we are having some water inside of unit weight gamma W, and it's occupying that volume of solids Vs. Can you see that? So we need to have some sort of equation such that we can get the Vs gamma W. So we need to get the Vs gamma W somehow. We need to get the value of Vs gamma W somehow. Let's try to get that. 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 Let's say that what's W4 minus W1? Let's make some Mahol. Let's make a Mahol. Let's say that what's the value of W4 minus W1? What is the value of W4 minus W1? Can you tell me? What is the value of W4 minus W1? Value of W4 minus W1. Is that actually is this only equals to actually that volume of V1 plus Vs times gamma W? Is the difference equals to the volume, the weight of water, the total weight of water, capital W? So this is actually the weight of water, capital W, and it's having some volume of V1 plus Vs times gamma W. So that is your weight of water. So that is W4 minus W1. And if I say what is the value of W3 minus W1? Yeah, W3 minus W2, I think. If I write what is the value of W3 minus W2? W3 minus W2. Can you calculate W3 minus W2? W3 minus W2. What is the value of W3? Can you tell me what is the value of W3? W3 is occupied by weight of pictometer is there. Okay, weight of pictometer is there in the W3. There is some weight of water. There is some weight of water because of volume of V1 times gamma W. Because of V1 times gamma W. And there's one more thing, that's weight of solids in volume of solids Vs. So I can write directly that this is some weight of solids. And I had to subtract that W2. Can you now tell me what is the value of W2? Your W2 is actually that weight of pictometer, then plus there is one more thing, that is the weight of solids. So what we got from this one? Can you simplify it? What is the value we got? So we got some value of W pictometer. Yeah, we got some value of V1 times gamma W. We got some value of V1 times gamma W. So this part is over, this part is over, this part is over, this part is over. So we only got from the W3 minus W2, that's equals to V1 times gamma W. And if I simplify that, what is W4 minus W1? That is V1 times gamma W plus Vs times gamma W. Now, I would say your value of W4 minus W1 is actually W3 minus W2. But we had to do some more stuff such that it becomes exactly equal. So there is in this one W4 minus W1, there is extra part of Vs gamma W. There is extra part of Vs gamma W. So I can have that from the right side. I would say we have to add one more part, that is Vs gamma W. So your equation becomes that W4 minus W1 is equals to W3 minus W2 plus Vs gamma W. So what we need actually to solve? What was the need we had to solve? What was the value we had to solve for? We had to solve for this value of Vs gamma W. Can you get this value now from this one? Because we are calculating only W1, W2, W3, W4. So we need to remove this part now. So let's go for that. I would say your G value becomes now weight of solids by Vs gamma W. So that we can write here W4 minus W1 minus times W3 minus W2. And can you tell me what is the value of Ws actually? What is the Ws actually? So Ws is actually dry weight of soil. This is actually dry weight of soil. Can you say that this is actually dry weight of soil? That is the dry soil we have. Here we have some weight of dry soil, that is actually weight of solids. Dry soil. So we can write Ws is actually W dry, that is W2 minus W1. So we can write then finally your G becomes W2 minus W1 divided by W4 minus W1 minus W3 minus W2. And if I want to remember it, I can write it in one go. We can write it in one go. So this is your W2 minus W1, that W4 minus W3, then W2 minus W1, 4, 3, 2, 1, 4, 3, 2, 1. In this way also we can have this. So whatever way you can have, that's your G value. While your W2 minus W1, that's the dry weight of soil. That is the dry weight of soil. You can keep that also. Dry weight of soil. That was your value of G. So this is only used. Here we need one thing, we have to ensure that the soil should be in dry condition. So for the calculations of specific gravity, your soil mass should be in dry condition. But if you're calculating for water content, your soil mass should be moist and your G value should be known to you. That G value we calculate from this method, from the same pictometer bottle. Okay, that was all from for this lecture. Thank you for watching that. Thank you for watching.